Okay, this is 2015, paper 2, question 3. The coordinates of 2 points A and B, 4 minus 1 and 7t. The line L1, 3x minus 4, 1 minus 12 equals 0 is perpendicular to AB. Find the value of t. Perpendicular means that we know the product of the slopes must be equal to minus 1. Alternatively, when we find one slope, we can flip and change the sign to find the other. So the first thing I'll do here, if it's perpendicular to AB, I'll find the slope of AB. Label them x1, y1, x2, y2, and I'll apply my slope formula. So after applying the slope formula, I know the slope of AB is t plus 1 over 3. I know that the line L1, 3x minus 4y equals 12, is perpendicular to AB, so we'll find the value of t. So I can find the slope of this line by rearranging it in the form y equals mx plus c. So now, once I have it rearranged, I can spot what m is. I can say that the perpendicular slope m must be equal to minus 3/4. So if it's perpendicular to that, I flip and change the sign. So positive 4 over 3. That must be the same as this slope. So I'm going to equate the two of them. So now the two slopes are the same. We can see the common denominators are the same. So therefore the top lines must be the same. So t is equal to 3. Find in terms of k the distance between the point 10k and L1. So this obviously points us towards the perpendicular distance formula from our tables. The perpendicular distance between a point and a line. So I have my formula. So I'll need to find out what a, b, and c are, and what x1 and y1 are. x1 and y1 are the point p. It's the distance from the point to L1. So a is 3, b is minus 4, c is 12. So I just fill those into my perpendicular distance formula. So once I've subbed all those values into the formula, I just need to simplify. So once simplified, I can see the perpendicular distance for the point P to the line L1 is the absolute value of 18 minus 4k over 5. That's because the square root of 25 will give me the 5 underneath. Okay, so part C, 10k is on a bisector of the angles between line 1 and line 2, and they give us the equation for line 2. Remember, we already have the equation for line 1 above. Find the possible values of k. So we have line 1 and line 2, my two black lines. P is on the bisector of the angle, so P lies on that red line. If it's on the bisector of the angle, that means its distance from L1, this distance here must be the same as its distance from L2. We already know its distance from L1. It's the absolute value of 18 minus 4k over 5. So if we find its distance to L2, we know those two distances must be equal to each other, and that will help us out. So let's start by finding the distance from the point 10k to the line 5x minus 12y minus 20. And we use the perpendicular distance formula just like above. So once again, we've got our formula, we've got our point x1, y1, we've got our line, which gives us our a, b, c. So we fill it into the formula and simplify. When we input those values and simplify it out, we get the distance from the point P to L2 is the absolute value of 30 plus 12k over 13. And then we just recall that point P is the same distance to L2 as it is to L1, which we already know. So to find the value of k, I can let those two calculations equal each other. We have two of them equal to each other. We can kind of cross multiply. Now you have different options here. One option to get rid of our absolute value signs is to take both sides and square it. That's absolutely fine. You'll end up with a quadratic. You'll get two values of k. That's perfect. There is one other option here though, and that's simply that we just take the positive and the negative of one side, which seems a little strange because the absolute value of two sides, but it works out just fine. So I can just say 30 plus 12k over 13 is equal both to the positive and negative of this absolute value, and I change my brackets to rounded brackets there, all over 5. So what we'll do is we'll cross multiply our 5 and our 13, and then we'll see what we have. So when we cross multiply, our 5 multiplies in the left, 13 multiplies in the right, and we get the following. 150 plus 60k is equal to plus and minus 234 minus 52k. So now we break it up into both the positive version and the negative version. So 150 plus 60k is equal to the positive of the right, which is 234 minus 234 minus 52k. Or alternatively, we've got 150 plus 60k is equal to the negative of the right. So that's negative 234 and then minus 52k plus 52k, and then we just solve. So bringing our k's to the left and our numbers to the right, we have two values for k. K is 3/4 and k is minus 48. So we found two possible values of k. If k is greater than 0, find the distance from P to L1. We already have the formula for the distance from P to L1. We did it in the second part. It's the absolute value of 18 minus 4k all over 5. If k is greater than 0, then our only option is to use the 3/4. So filling that in, 18 minus 4 times 3/4 all over 5 will give us the distance from P to L1. And our distance turns out to be 3 units.